Okay, we'll continue working through our packet. We got through most of pages 1 and 2. And next page in page 7. Okay, this is a volume surface area problem, much like volume of a sphere. Same process, we find the derivative, we just plug information in. So why don't we try number 8? Today I definitely want to go over volume, shadow, and yeah, I'll do area of a triangle. Okay, give that a try. I will walk through the steps with you, but we'll see how far you guys can get on your own. So find dV/dt, find ds/dt. See if we can label the values for the variables. Okay. Okay, so here's my first step. Finding the derivatives. Yeah, this back there. This is a test repeat. Oh. Oh, what's repeat? Oh, thank you.
When did you do this one out?
We went over this Friday. We did first 2 pages on Friday. dV/dt is -10. Trying to solve for ds/dt. Okay, I'm looking for DSDT. But if you look, I need X, I need DXDT. So they're not giving that variables to us, but they are giving us surface area information in dvdt. So with the surface area, maybe we can use that to find X. Once we find X, we can use dvdt to find DXDT. And then we have the final two pieces that we need to build our DSDT variable. Okay, once we solve for DXDT, then everything should be pretty straightforward. Plug in 3 in for X, -10/27 for DXDT, and you can find DSDT. Notice units of measure, square meters per hour, DSDT, the surface area.
But negative is decreasing.
Decreasing, right? But this should come up on its own. DVT is negative, so we should have to put the negative there. It should show up when we plug in.
Normally we show up, or sometimes we define, like, make sure.
If we define the variables correctly, our answer should always be the correct sign. So here we have to make the decision that DVT is negative. Okay, let's try number 9. Nine is a Pythagorean theorem problem. Okay, so jet A travels due east from San Francisco towards St. Louis. Jet B travels due north. Find the rate of change of the distance. Okay, Pythagorean theorem. Yes.
If I drew the triangle the other way, is that bad?
Well, we kind of have to follow what this says, so. Yeah, make sure you follow the direction that they tell you. So east, you gotta fly to the right. North, you gotta fly up. How did you draw yours?
Oh, I just thought the line going down would be south, but I guess, never mind. Cause
Yeah,
always,
because they're telling us which direction the two jets are traveling.
to meet at the same place.
Yeah, they're both headed towards,
Okay.
St. Louis. The diagram makes sense.
Yeah.
Okay, Pythagorean theorem. Okay, what's happening to X as jet A closes in on St. Louis? Smaller. So what do you expect out of dx dt?
Negative.
Negative. What about dy dt?
So
Also negative. What about dz dt?
negative as well.
Also negative, right? So the triangle is getting smaller, so every rate should be negative. Every rate is decreasing. Every length is decreasing. Okay, so jet A travels east towards St. Louis at 500 miles per hour. What can we put in for that?
500, negative 500.
For dx dt. Okay. St. Louis, dy dt. Find the rate of change when the two jets are 300 miles apart. That's what?
Negative 300. It's easy.
This is 300 miles though, not miles per hour.
It's easy.
Just z. Okay. Jet A is 100
Oh, we're
miles.
looking for easy.
Yeah, we're looking for dz, right? Jet A is 100 miles. So Pythagorean theorem can get you to y. Careful, it's not just 100, 200, 300. That's not a Pythagorean triple, so you got to go through. It's going to be a decimal value. But once you get that, then everything is just in the calculator and solve for dc dt. Okay, after this, try number 10. Got the shadow problem with similar triangles. Okay, everybody okay with Pythagorean theorem here? Okay, try number 10.
We're gonna do it, no problem. I mean,
Yeah, let's do it. We can do it, no problem. We have time for that. Always starts off the same way. Okay, see if you can practice setting up your proportion equation.
I was wondering, why do you like divide it like into X and Y? Then
Just so that we can have all the pieces that we need, because dx dt is going to represent how fast the person is walking. Dy dt is going to represent how his length of the shadow is changing. And that way we can do dx dt plus dy dt to get the tip of the shadow, rate of change at the tip of the shadow.
it's not like you moved, like he's moved closer, right? Rather than going straight down.
I mean, if he's moving closer, it's still going to form a triangle. His shadow length is going to decrease, and it's still going to be a triangle within a triangle. But does this equation make sense?
That portion makes sense.
Yeah, if you can set this up, then just cross multiply, clean up, and find the derivative.
Maybe that's like the small triangle, big triangle.
Right. Mhm. Okay, so once you cross multiply, we get 6x plus 6y equals 16y. Combine like terms. Find the derivative. And we have to understand what each of these represent. dx dt is the rate of change of the person walking. dy dt is the rate of change of the shadow length. And the two rates added together is the rate of change of the tip of the shadow. Okay, so we have dx dt, which is -5. Plug that into our equation, solve for dy dt, and that's part A. The part B, which is add the two rates together, the person and the shadow length combined together is going to tell us the rate of change of the tip of the shadow. Okay, let's go to page 7, number 10. Sorry, page 17, number 2. Okay, let's try a code problem here. Okay, so try setting it up, see how far you guys can get. I'll walk through the steps with you, but I'll see how we do here. Okay, page 17, number 2. Okay, so here's my proportion. R over 5 equals H over 8. I'm looking for DHDT, so that's going to give me an idea of how I want my volume equation to look. I would like my volume equation without the radius in it. I'm going to solve for R, so I can replace R in the. Again, careful with that H before P. We did not use that till the end. Use it too soon, you lose your H variable and you can't get your DHDT to show up. Okay, so there's my substitution there. R equals 5H over 8. Replace R with 5H over 8. Don't do derivative yet. Clean this up. Distribute. Get all your fractional coefficients together. Get your H's together. And then make your derivative. So we're saving the calculus until we have a nice and clean equation. Right, now we can find PVDT, right? PVDT, coefficient stays, H cubed becomes 3H squared. And then you can start putting information in and just make sure that you hold on to your pi as part of your final answer. Okay, let me know if you have any questions. You want me to clarify any of the steps? Hopefully, you guys feel comfortable going to tomorrow. We've been doing this every day for the past few days, so hopefully we're getting there.
For the four compound at the bottom. But they plugged it, yeah.
It's four.
Yeah.
This four came from the fact that H is 4 feet.
Uh,
So I didn't want to use it until after the derivative step. Yeah, so we are going to use it, but not until the end, until now.
So it's gonna be like one of each problem.
Yeah, so on the quiz, you get a code problem, linear approximation, L'Hopital's rule, the diagram theorem, and then I'll pick two from this list. You can either get a volume surface area with cylinder, sorry, with spheres, a shadow problem, cylinder, area of a triangle, area circumference of a circle. So we get two from this list.
Which ones haven't we reviewed yet?
I think we've done every one of them.
We did the circle one?
Uh. Area circumference of a circle. No, we didn't, but it feels very similar to the volume surface area that we did for
Okay.
squares. You just find the derivative and just plug it.
We do a linear approximation.
Yeah, we can do that. Okay. Does anybody have any questions here? Okay. All right, so page 14. Let's do 6 and 7. 6 is a limit problem. And 7 is doing an approximation, but I want to reword it a different way. More similar to what you're going to see on the quiz for number 7, but try 6 first. Okay, first step. What do we get? Direct substitution.
There.
0/0. So that gives us the green light to do L'Hopital's rule. Power rule for the top.
Squared ones. 3 squared.
Yes, 3 squared, good. Power rule for the bottom.
And then 12x² minus 1.
Yeah. Okay, reevaluate. And we stop once we can reach a real number.
Six and seven are two separate problems, right?
Two separate problems, right? Okay, thanks. Okay, so 7, the function is 1 over cube root of x. Use linear approximation to find f of 8.04. First thing is we want to use the closest integer value so we can build a nice, clean tangent line equation. So what x value should we use? 8. Yeah. So find your order pair, find the derivative, find the slope, point slope form. And once your tangent line equation is ready and set, you can involve that 8.04 at the very end. I brought the x up to the top to go through power rule. Found the derivative, plug in the 8 to get the slope. Okay, have my order pair, have my slope. Build your tangent line equation. And then your final step is to plug in that 8.04. Did we finish number 6 on page 6? No, okay. Let's do that one because that one has the area of a triangle in it.
Probably even started this.
Oh, did we not start this one?
Might have.
Okay, yeah, let's set it up and try number 6, page 6. Everybody okay here? So we have a boat that's pulled toward a dock by a rope. 6 feet. Dock is 6 feet above the boat. And the rope is being hauled in at a rate of 2 feet per second. Okay, Pythagorean theorem here. Okay, the rope is being hauled in at a rate of 2 feet per second. What is that referring to? Okay, anything special about DVT? What's happening to that length of the rope? So. Negative, right? The rate is negative. We're trying to solve for dx dt, that's the unknown. What do you think dy dt is equal to? Y. Does not change, right? That height is never changing. It's gonna stay 6 feet the entire way through the problem, so the rate of change is 0. The rest is just plugging in. Okay, part B, at what rate is the area of a triangle changing? Here's the area of a triangle. Trying to find the ADT, so 2 variables here being multiplied, I gotta go through one. And then what's the units gonna be? The ADT. Area is feet squared per second. Feet squared per second. Okay, let's do one last one here. Page 11. Cylinder problem here. Sorry, page 8, number 11. So watch out for cylinder problems. You're most likely, a lot of times you have extraneous information that's good for cones, but not needed for cylinders. The second, your radius can just be removed, replace the radius with a constant value. And there's no need for cylinder triangles, it should go a lot faster than cones.
Is height one of those extraneous usually?
I'm sorry?
Is height usually an extraneous, like,
Yes, that's right. The height is typically. Any questions? Okay, so make sure you memorize the formulas that need to be memorized. Help session this afternoon and tomorrow morning. And make sure you bring your calculators. I'll send out a reminder this afternoon. Okay, don't forget your phones. Quiz tomorrow.
that's not how we should be.
Zoom.
Do we?